Okay, today we're going to introduce and try to understand what a logarithm is. A logarithm, log for short, is an exponent just written in a different way. What do I mean? Well, if you look down here at this setup, the a is the base because that's what's holding the exponent. The exponent is the y, and a to the y equals the value x. What do I mean by the log is an exponent? Well, check out what happened. The exponent was y, and now it's what the log equals. So the log is equal to the value of the exponent. The base becomes the base of the log, meaning it's literally at the bottom besides the word log. And the value x is what you're now taking the log of. Okay, what does this even mean? Why do we have this? Well, it's a way of solving an exponential problem. We did exponential problems last chapter, and we talked about y equals a times b to the x, and x was an exponent. That's fine and dandy as long as they're telling us x values, but if they ever ask us to solve for the x value, we have to have a way of getting x out of the exponent position, and that's what a log does. A log takes that exponent and gets it by itself, so we could solve for it because it's over here by itself. When I'm working with logs, I like to remember this little phrase. When it says the log of a with the value of x equals y, that literally means to me, if I remember log is an exponent, that means the exponent of a that gets me x is y. The log is the exponent. I'm solving for the exponent. There's two conditions that make that you have to match. Okay. The two connections are that a has to be positive and not a 1, because if the base is 1, then it's just going to stay 1 no matter what your exponent is. And that the x has to be positive. It's impossible to take the log of a negative number. That gets you an error message. Okay, so first we're going to just practice rewriting the format and getting used to it. So if we start with something that's in a log, we have to remember where the base is. The base is on the bottom. And where the exponent is. The log equals an exponent. And so if I write this in my familiar little format, I would have 2 to the power of 5 equals 32. And I can double check that really quick that that's true. 2 times 2 times 2 times 2 times 2. I think that was 5 2s. Equals 32. Okay? Another one. Where's the base? It's on the bottom. So 10. Where's the exponent? Logs equal exponents. So the exponent is that 0. And the value is the answer, 1. And sure, if you remember way back when, anything to the 0 equals 1. So that's true. Or one more. Hey, the base is on the bottom. Yes, the base can be a fraction or a decimal. So 1/5. I'll put that in parentheses so you can tell the whole thing's to the power. Speaking of power, logs equal exponents. So -2 is our exponent. Equals the value 25. If you remember that a negative exponent causes the base to flip over, 1/5 would turn into 5/1, and then you would square it. So 5 times 5 would become 25. That one makes sense too. Okay, what if we do these the other way? We need to find out the base. The base is what holds the exponent. Wow, I totally missed right there. The base is your 4. Your exponent is your 2. This is usually tougher for people to do at first. So you have to remember to write the word log. The base goes on the bottom, down by the tail of the G. It's a subscript, so you want to put it under your line of writing. You're taking the log of 16, and logs equal exponents, so the exponent 2 goes to the other side. If I think about that little sentence I told you, this means the exponent of 4 that gets me 16 for an answer is 2. Sure, 4 squared is 16, that's true. All right. On this one, the base on the bottom, that's that 100. Exponent is 1/2. So we have to write the word log. I'm going to sneak it down here where I have a little more space. Base goes on the bottom, so I'm going to write the 100 down by the tail of the G. I'm taking the log of the value 10, and the answer comes out to be the exponent 1/2. Logs equal exponents. So if I think about that sentence, the exponent of 100 that gets me 10 is 1/2. That might not make a lot of sense to you right now, but that is a true statement because a square root is the same as an exponent of 1/2. So it is a true statement. You could type it in your calculator and verify. All right, and one more. Here's our base is 9. Our exponent is 0. So log, write the 9 by the tail of the G. We're taking a log of the value 1, and it equals the exponent 0. All right, so writing logs and exponents. Okay, the last skill for the today is to use that phrase, the exponent of whatever that gets me this answer, to try to evaluate, find the number, the missing number here. So in this first one, this is 3, and that's a base. And the answer, the value here is 81. And what I don't know is what it equals. That's what I'm looking for. So the base is 3. Logs equal exponents. So I'm looking for the missing exponent. 3 to what exponent equals 81? That's my question. And so then I just have to experiment with that. Guess and check, if you will. I know if I do 3 squared, I get 9. If I do one more 3, that would be 3 to the 3rd, I'd get 27. So I try one more, 3 to the 4th, and oh yeah, it comes out 81. So there's just a little guess and check. So I needed 4 3's multiplied together to get that. Okay? This next one is a lot easier for people, a lot more accessible. If my base is 5, and my answer is 25, what's my missing exponent? A lot of people can do this mentally. They think, what is the exponent of 5 that gets me 25? Oh, the exponent of 5 that gets me 25 is 2, right? This, if I wanted to rearrange it, be 5 to the something, and the answer is 25. If you need to rewrite it to visualize it, that's fine. We're in a learning process. Okay, one more. I'm going to skip this one on the end here. All right, the base, think about it, think about it, think about it. The base is on the bottom, the base is that 8. I do not know what it equals, which means I do not know the exponent. So I'm asking myself, the exponent of 8 that gets me 1. If the answer is 1, and the exponent is not 1, I mean the base is not 1, then we know the exponent must have been 0 to make, because anything to the 0 power equals 1. That's the only way that would work out. Okay, if you have any questions about introduction to logs, please ask them in class.